Hi, I'm Jerry Q. I'm going to show you a nearly no-code solution to a complex problem, built in weeks, delivered bug-free to date. All the logic lies in the data structures you'll see here and generated SQL, and not in traditional coding. I'll lift the lid in the hope that these methods will be explored for wider usage. This solution is two distinct no-code layers. One is a stage gate mechanism for display and logic, and implemented on the top of that are a number of company apps. First, the problem. My partners and I have set up a business to supply a variety of extremely high-quality ingredients, some in limited supply in boxes and hampers, defined by celebrity chefs, with frequently changing content. Let's pay a visit to sourceit.net to see the results. A very traditional e-commerce website with products available for sale, detail on the products, descriptions, details about ordering and dates and so forth. Much greater detail on each of the different products in the hamper, with greater detail including specification available, and so forth. This video is not about this website, but rather the back-end systems to underpin it. As you will have seen from what you've looked at, we'll need back-end systems to support frequent new hamper definitions, requiring product sourcing, costing, upstream supplier agreements, marketing and legal collateral, pictures, specs, description. The products are sold for a number of weekly picking cycles to ensure fresh make-to-order of the ordered hampers. For each weekly cycle, we need the upstream suppliers to contract to supply product up to a predetermined number. Then we can sell, knowing we have the commitment to supply from our partners. When a sales cycle closes, we place upstream orders, generate picking lists, pick and dispatch labels. I modelled and built the raw database structure necessary to underpin this in about 1 day at the most. The key tables relating directly to what I've just described are: we have hampers, which contain products, and each hamper has picking blocks. A picking block represents a sales cycle. Picking block will go on sale for a week. Orders will be taken against that picking block, and then the sales complete. Once the sales are complete, then bulk orders need to be placed upstream. I'll be explaining the other key tables in this data model during the progress of this video. Some basic traditional code scaffolding, so to speak, was made to allow the entry of our launch products whilst I was building the main solution. We've since replaced those scaffolding products with no-code solution. In the course of a 3-week period, I built a generic no-code tool to underpin the solution. I populated the metadata, which is the tables of this color scheme on the right-hand side of the model. I populated that metadata by hand, entering the database in rows in the metatables. Since then, we've had a simple maintenance tool built to edit that metadata. The result was this. This is a stage gate screen. We can see that hampers start life. Their contents are edited, the attributes, so we can gather and make sure that all of the attributes for each object, the hamper and the individual products, have themselves been entered. because we don't want to move on to the next stage until all is complete. And oh, look, it's not ready to go. Why is it not ready to go? Well, we can see that one of the upstream gates of being ready to go is shut. It's clearly the something text to do with gherkins on olive oil. And we can see that the long description hasn't yet been approved. Let's dive in and approve it. Update. Now we can see that gate has opened and the hamper is now ready to go, so to speak. It can be published as a picking block. The next step towards publication is this, where the picking block, upstream contracts, one for each supplier, containing the contract for the provision of product, and PDFs have been generated of the contracts. Gates are all open. It was able to open for business, and then subsequently the upstream orders have been generated. They were generated by pressing a button here, which at the moment is not available because the gate has been opened. Let's close that gate again. And we see that we get a button to generate the order PDFs. By now, mark that task as complete because I had actually done it before this. Then the relevant downstream gates pop open, and we're waiting for confirmation that they've also received their self-billing invoice, which we've generated. And similarly, as we work our way down, we can set all of those to open, and then we're able to generate dispatch labels, picking lists, perform the pick, and dispatch the goods. All of this functionality was delivered with, to all intents and purposes, no code. I'll be lifting the lid and revealing how it was done through the rest of this video. I'd like you to consider this beautiful 9-planet orrery built by Tim Staines of Staines & Sons. The logic is entirely expressed in gears. At rest, careful examination would predict its behaviour. The logic is embedded in its structure. In order to make it, it was defined, built, snag-fixed and delivered. The logic is expressed in gears. The idea of a test and debug cycle is not really relevant. You're not going to have a minor issue in one area triggering problems in another, for example. The stage gate process you've just seen shares these qualities. I'll explain. Let's explore the most basic building brick of these code-free and nearly bug-free methods. CAIR, create all inferred rows. Here's a simple, robust app built in about half an hour. It's not pretty, but that's not the point of this. Here we have a model whereby we have students, we have classes, and an intersection of those two, which is student-class relationships. These are represented as 3 tables in the database. Let's have a look at the front end of this one-page app. As we can see, there's a simple grid. If we select what courses people are planning on taking, we can update this grid, and we've got that in there. We can add courses to it. And we can add people. This entire app is built and operates in a single page. Let's have a look at that template. The template is written in Cold Fusion, Lucy, which acts as the glue sticking the SQL together with the HTML. The SQL, we'll see how that is built shortly. It's self-referential, so that if we add a class, it's a form within the template, which when submitted, submits to itself, and it's carrying the function required as one of its values. So if we arrive in the template carrying the variable form add class, then a row is inserted in the class table, and then the magic is run. CAIR student class, create all inferred rows. We'll have a look at this now in the database. I've opened a query window in the related database into which I'm going to paste that CAIR query we were looking at. Let's explore how that query was built, and then we'll explore exactly what it does. So first of all, it's an insert query to insert new rows into the student class database. So first thing we need to do is build an insert query. So I'm going to design a query in the editor, take student class, select the columns I'm interested in loading, turn it into an update query, and pop it in here. Here's the syntax we want for inserting rows. These are the columns we're going to insert, but we aren't actually going to use the values clause to do it. The next thing we need to do is decide on which rows are necessary to go into that table. If I make a view using student and class and select both of these columns, I get given a cross-join syntax here, which, if I execute it, a cross-join makes every possible combination of student and class. I'll clear that now because I've actually made that earlier, but I wanted you to see it being constructed. So we'll clear that syntax and we'll look at this view. And this view is called all possible student class. VW, view all possible student class. It is that query that we just built. So that's stored in the database. So if we go back to our view editor and we add that table, or virtual table, all possible student class, and we add the student class table, and we join the all possibles with the actuals, we select all rows from this regardless, unless the corresponding actual is not present, is null. So if I now execute this view, I get no rows because all of the required rows are already present. However, if we add a new student to this, then the situation has changed. If we go back to here and we execute that view, which takes all possibles and identifies those which, although desired, are not present because the corresponding row is null, then we get the rows that need to be added. If I now lift that syntax, take it back to the query we were building, and paste it in, we'll see it's exactly the same as this, with one exception. We want to automatically default to inserting a 0 into the attends true false. That in fact can be built into the database as a default value for the column. If I now select this syntax in the database and execute it, 5 rows are inserted. If I execute it again, no further rows are inserted. This is called idempotence, and is a very important concept to systems design. Idempotency is building everything such that processes can be repeated and the outcome will be the same. We can repeat this, and always the student class table will have all the rows it needs and no other. Returning to the grid, we can see that our updates that we did manually in the database have been applied. Now Yvonne is active in that grid. Going back to the code, let's explore the entire template. We've got add class, which inserts into student class and then redirects itself back on itself so that a refresh will not add the same student again. Almost identical code, but totally identical CAIR function for inserting new students. And if the grid is supplied, in other words, they've clicked update, then the function gets all of the rows from the grid with their student class IDs and loops through them, and depending upon whether or not the tick was supplied, the attends status got altered. And now this is the display. The display gets the grid in order to show the checkboxes. It gets the students in order to show the left-hand key. It gets the classes in order to show the classes across the top. And then it works through those, doing extremely simple functions of looping through that SQL. It's the button to update the grid. Is the add student, and then finally the display of the students and the classes they attend. That was the simple building brick, which, as you can see, could very simply be built upon. We have a table of days of week. We can care which classes occur on which days. If we have a table of dates, we can care student class to individual dates based on the day of week, producing in effect a daily register. This little app can grow in richness and complexity to all necessary levels very simply. And from simple bricks, rich structures may be built. Next, we'll have a look at how the stage gate machinery works. Let's examine the data model, what in Orrery terms one might think of as the gearbox. It's worth noting that with my modelling technique used here, one-to-manys are expressed vertically. If there's a line, it represents a one-to-many relationship. The bottom end of the line is the many end of a relationship. the top is the one end. This is important. This model is divided into three regions. There's the raw data, which is the hamper product, the picking block, and bulk order. There are further things associated with this, carts and baskets and hamper instances, and they all flow directly from this and inherit the same characteristics as everything I'm demonstrating to you today. The metadata, related table tells us which tables in our business database are covered by this stage gate. The related table to related table describes the relationships between those. Stages, each of these represent a stage with a treatment. So this product stage has got 1, 2, 3, 4, 5, 6, 7 subjects in it, and each of those subjects has a number of tasks. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, approximately 10 tasks associated with that subject. And each of those tasks have data type of potentially integer or text or image or document or whatever, which are expressed here. This region is the region that is built by CAIR philosophies. So we have a CAIR process, which we will walk through, which creates all stage gates which are implied by the content of the metadata here. This is being the metadata section. This is the most complex CAIR, which we will explore in detail. And then that lays down using CAIR, just like you've just seen, to lay down all subjects for each instance of a bulk order or a picking block, or in this case, products, hamper products. This stage gate here is represented by a row in here. And stage gate to stage gate draws upon this table and this table to lay down all of the required stage gate to stage gate. This in turn allows us to execute all of this logic here. So if I unset this one, then we can see that the stage gate point reaching where this is the output gate, has closed because one of the gates upstream to it is shut. Resolving these is simplicity itself. For any one task, it has a true-false status. And with a single query, we can take the minimum value of that true-false status, which in this case is 0, and we can apply it to the true-false status of the subject, or rather the stage gate subject. The minimum value of all of the subjects in a stage gate determines whether or not the stage gate is open or not. So the minimum value, because this will be 1, 1, 1, 1, 0, 1, 1. That minimum value is 0, thus this gate is shut. And similarly, using the stage gate to stage gate, this stage gate has its status, its input status, its entry status set to the minimum value of the stage gates directly upstream of it. And thus the entire logic is executed. It's worth noting, incidentally, that these update panels, which allow me to update everything of that particular stage gate, those update panels are capable of being served with simply defined different columns, etc., and rules can be served as an API for the consumption of a more traditional interface environment or an external service offered to somebody outside the business to connect to our business. I have switched on debug mode so that we can explore how this screen was constructed from a database SQL level. If I scroll down, there's a bunch of environment. The whole screen took 369 milliseconds to be constructed, of which 328 were spent on query execution. There are some environmental queries to do with the context of this application. This is the priming queries to start with the initial entry stage and begin the steps of going through the next stage gate. And then this is the crucial central query. Okay, next stage is to explore the metadata editor. So now we're looking at the hamper stage gate flow, and we can see still that this one requires to be set. And update. And we should see now everything is green and this gate is opened. Let's go and have a look at the metadata edit. So first of all, let's look at the stage-to-stage relationship map. So if we click on map up on the top here, we can see the stage setup for this stage map. This is the hamper stage map, and this is the relationship between the stages. We enter through the start hamper. There's a one-to-one relationship with the hamper, and there's a one-to-many relationship with the products involved. And similarly, the opposite direction, there are many products relate to the final stage, and there's a one-to-one relationship between hamper and the ready-to-go stage. So here we are with the hamper ready-to-go stage. Let's look at this. And it's got one value. Let's add to this the ability to just do one final edit before we're ready to go on the long description for the hamper. So the long description was in fact set here. There we go. And now we're going to create the opportunity to also set it here. So we'll go to the stage editor by clicking this. And here we are, the ready to go hamper with the recheck hamper. So I'm going to add a new subject. I'm going to call it long description review and edit. That'll do, still there, and we'll give it the header icon of text. Add the subject. And we can see down here we've got this, and we now want to add another task, a task to there, which we will call review stroke edit long description. It's a data type of text. And to add the task, there we go. Now let's edit that task. It's a coupled value. In other words, it takes the data from the database and subsequent to edit it pushes it back. This is the column that is used, that is from the hamper table that we can see up here in the model. We can switch off the delete button because we're happy with what we're doing here. You can see all sorts of things that you can set for behaviors, including firing actions, related tables. So for example, in the previous stage, hampers can create offspring products, and you can even determine what's to happen after an action. I've edited the task. Next thing I need to do is run the full-blown CAIR. CAIR all. That's done the CAIR functionality. And now when we refresh this page, we can see that the ready to go stage now has a new column, which if we examine that column, it's loaded with the values, and there's a checkbox to say I finally approve of it. I can select update, and it's worked. So we've modified the system in a few simple steps through the metadata. Our next step is to explore how this table, this stage gate display, is built out from the database, again without code beyond standard SQL. We'll be exploring the CAIR all a little bit later for now, but let's look at how the page is built. First things first, I'm switching on dev mode so that we can debug and see the queries that are involved. If I scroll down now and look at the rendered page, the rendered stage gate, I can see that the entire thing took 700 milliseconds to build. I refresh and it was 327 there. That's because it's been a while since I last fired the code, so some things have dropped from cache. But a total execution, so 7 milliseconds of actual page build and 300 milliseconds of SQL queries. Now you'll see that there are some environmental queries that are run to start with, but then the main query that gets us everything that is used to build the page is this one, which sources from the database, and in this case took 94 milliseconds to run and returned us 5,200 rows, constituting the stage map for hamper. All subsequent queries in this are extremely fast because they are in fact query of query. They take this query result set and apply SQL in memory. So this one took 4 milliseconds, this query took 0.3 milliseconds, 0.13 milliseconds, and so forth. So we can see there's many queries run to build the page, but they are all extremely fast. Our next step is to explore the construction of that master query. Let's lift that master query off the page. And we'll drop it into a query window in SQL Server. Looks a bit scary, doesn't it? It's not really. This query, which will execute quickly, returns all of the rows with all of the appropriate metadata and the fact store, the data types, all of the relevant information possibly necessary for every single appropriate stage, gate, subject, task. Something to observe about this modelling technique is that because this is many to one and 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 so forth up through all of these, it means that for every row of stage, gate, subject, task, all of the values of all of the columns of all of the databases in these tables can be considered, because there's only one set for each of them going up that route, can be considered to be attributes of each stage, gate, subject, task. Thus you can ask for all of the stage, gate, subject tasks that are relevant with their full metadata context. Let's take a look at that. So this looks like a scary query to write and looks suspiciously like code due to its complexity. This is not true. Let's now go to create that view, that query from scratch. Requested a new view, and I'm going to need these tables. Add all of those, and these are cross-link views to the metadata columns. And we want data type, stage, subject, task, user. User, incidentally, is we record the user, which is not showing on this model, who did the type, date and time a particular user approved a particular task at the stage gate. So we add those. So if I take stage gate subject task, drag it over here, stage gate subject, stage gate subject task key. This is a unique key to allow an MD5 base to allow external access. Didn't mean to add that one. We've got data type, we've got task, we've got subject, we've got stage, and I've got user here. Last set true by the dual column primary keys, by the way, for anybody's interest, is to allow for database sharding for distributed performance needs, should we choose to implement that. It's something by default I put in. Data type, subject, stage, and we can start grabbing any values that we want from any of these columns. We'll go and lift them in a minute. And what's the name of the task? What's the name of the data type? What's the name of the subject? Stage name, and stage ID to there, and a couple of columns from there. And we execute, and look, the query just works. All of this complex join simply works because of the power of CAIR. I'll just flip this so that you can see. This is as though this model has been rotated 90 degrees to the clockwise, because let's have a look at this. This just shows you that, in fact, although it lays it out slightly differently in the query window, it is in fact the same as our data model here. If I go back to the SQL that I ported in here, lift this and drop it in here, it preserved the layout, and then here's the actual query. My point is that designing and defining that seemingly complex query took no more than 5 minutes and was simple to return to as we enhanced the application by adding new columns. It was simply a matter of revisiting this query, and I say added new columns to the stage gate systems. It was simply a matter of adding to this query and moving forward. Okay, let's walk the rendering process. The rendering of this stage gate straight from the data. The top level template is stage gate progress map, which, as I mentioned earlier, does some priming queries, because this is the very first stage and all other stages follow the stage, so that get next stage gates and get these column stages varies slightly between the start gate and all subsequent state gates. Once having run that, it then includes stage map display. You'll notice I've highlighted the cold fusion in here to indicate just how minimal the code is. It's really a container for the SQL. Stage map display, let's look in here. First thing it does is it includes this template which has the query we've just examined, the master query. Then it serves up formatting stuff, tables and so forth. Loops through the column stages, gets the next column stages, gets the next stage gates, outputs them. As you can see, there's not really code here. It's entirely driven by the data that comes back. And having formed up a stage, so like this one, so it's positioned it in this overall framework of the page here, where these are columns with rows in them containing stages. Now let's look at the render of one of these stages, and that's done by including the stage renderer. We look at the stage renderer. The stage renderer, if it's in a context where that hasn't already been run, then it goes and gets all of the base data, because these can vary in their context, the consumption of these templates. Subsets that. This is what's known as a query of a query. These typically take 1 or less milliseconds to operate, and it's running on against the query that was previously run. Get stage gate records for all instances, get all the subjects for the stage, set up some formatting stuff, loop through the subjects for the stage, and for each of those subjects for the stage, go and get the tasks for it and output it. As it goes to output it, if you remember, the individual subjects were divided into complete or not between green and amber. These calculations are done here by counting the number of tasks in each state within the subject and then outputting it. And that, in essence, is how that is built. The edit panel, when we click on something and we get to edit, it builds in a very, very similar way. It goes and gets all the main information, subsets it, and then asks for a common edit panel to be rolled. And there's that edit panel. And this is the one time we really see any ifs. Obviously, this could just as easily be a case statement. And it tells it how to treat each data type, how to wrap each data type in that edit panel. And so we go on through here. If people are interested in this, I'm very happy to go through this in much greater detail. But that's it. That's the no code. When the update is pressed, that fires the update subject task. And this is the update procedure, which, same trick, gets the lot, subsets it, walks through the tasks, and for each of the tasks, depending on the tick status of the boxes, sets completeness. Slightly different treatment for the update, dependent upon the type. So, for example, a new text value goes into the text value column, because the data type of 4 told us that, and that's quoted. This is the treatment for an image. This is probably the very closest thing to code of the whole thing. It's absolutely standard. It takes in the image, resizes it to a 1024 square, places it in the S3 data stores, resizes a thumbnail, and loads the stage subject task table secondary URL column with the thumbnail value. This loaded the storage column, the selected storage column, and that. And this is for uploading PDFs and so forth. So as you can see, the Cold Fusion is really about providing a container for the HTML and the SQL that we wrote. We spoke earlier about resolving the true falses. This is the true false. the stage gates, the exits are closed to start with. Then the stage gate subjects are zeroized. And then the stage gate subjects consume this view, which is the minimum value of the tasks, and loads the stage gate subject with it. The same trick is performed for the stage gate. Then stage gate, true falses, stage gate to stage gate, true falses are themselves resolved. Again, very simple SQL written in a very short time, and the code is doing nothing really beyond hosting it. Good news, we're on the home straight now. We're going to explore the views involved in CAIR. I mentioned earlier that there was some complex views that needed to be created for CAIR, so let's see how they are built. Here we are. Is the all possibles that we referred to, that you saw us build for the you saw me build for the student class project. So let's tear all of these out. I'm going to dispose of all of these views. Okay. Drop them. And then these stage gate to stage gate views, I'm going to delete all of those. It's an incredibly robust mechanism, by the way, in as much as I can nuke a great deal of the database and it will completely repair itself because of the CAIR philosophy. Anyway, meanwhile, back at this demonstration, if I look at, if I run this query which makes views, this template, so I've just run the template that makes views, and it looks to see what views are missing by exploring the schema, and then builds the relevant views. Here's the template we've just run, gets the stage related tables, sees if the view that needs to be made already exists. If it doesn't, it makes it. And then similarly for the stage gate, it makes all of those views. We'll now look at one of the views that's been created. So if I come back here and refresh the view window, all those queries that I've those views that I deleted, they're now back here. So let's look at the view for stage gate from hamper to product. This is the view that will be used to make these stage gate connections. And we understand its need to exist as a view from this map here, stage will be used to form the stage gates. Let's examine one of those. Hamper to hamper product. Design it. There's also another one from hamper product to hamper, both of which support the stage gate structure we've been looking at. But we did not have to write this code. Simply the existence of the rows in the metadata caused this view, for example, to come into existence. Let's just lay it out a bit nicer. Stage gate, stage over there, stage 1 over there, and hamper product. So if I now move these all across here, if you remember rightly, this is going from hamper to hamper product. So the hamper product table, the child table in the one-to-many relationship, has both sets of columns. So the from stage gate is the hamper ID, and the to stage gate is this one. This view is then used to serve up all of the these are all of the possible stage gate to stage gate IDs that are necessary. Using the CAIR philosophy, this gets used just like the all possible views that are made for the other form of CAIR. How does this work? Well, we're looking for two stage gates, and we want the stage gates to one stage to do the from connection in stage, one to do the to connection in stage, and this explicitly and this filters the related stages to stages which are for the appropriate table, related table. So this only takes stages that are for hamper product, and this one will be the same for hamper. So this entire view, which was written by the machine according to the pattern, is then used to guarantee that all of the necessary rows jump into existence. We'll now do a quick walkthrough of CAIR, and that's mostly it. So if we look at the stage gate CAIRs, this is the master CAIR script template, which, as you'll see, is primarily a container to carry pre-written SQL. So the first thing is it gets the stage-related tables and CAIRs the stage gate for each stage gate, so it loops through all of the tables and consumes the all possible queries. Make sure that this related table to related table is complete, because for each direction this goes, and it goes one to many, it also does the inverse of many to one. That's what this does, and that makes sure the base ones are present, and that makes sure that the inversions are all present. CAIR stage gate subject, loads that, subject task, clears any stages which are now orphaned because the stage has been removed in the course of edit. Similarly with those, goes and gets all of the stage gate CAIRs, and then uses those views that we just had the system built and we explored the structure of to do a CAIR to make sure all of these are present. Does some resolving, sets the entry point stage gates to open, because entry point to any one map should be open, and similarly another removal of orphans. Clears the stage gate. This prepare blank keys. This is to generate MD5 keys to allow us to send links to people outside the organization to be able to provide updates to targeted content. Then it searches for any tasks that have got coupled data and grabs the data from the raw tables and puts it into the appropriate fact storage column in the StageGate subject task. Similarly for any tasks that have got derived data rather than coupled. The resolve I was telling you about to set the stage gate summary uses this view to set it to the minimum value of whether it's true or false. Similarly for stage gate, another view there. I didn't show you, I will very quickly here. I wanted to set the coolness of a particular product. I've got a choice pull down. That came out of the metadata. The SQL to deliver the choices was loaded into the metadata through the stage maintenance tool. So this prepares the JSON to sit in the metadata to be consumed at runtime to offer those choices. Updates the labels to mark the different stage gates so that when we're looking at them on the map, we can, on the stage map, we can see what each of them are called. We update the labels, and finally we do the resolve true falses, which is kind of repetitious because we've already done them a bit earlier, but I think that's to make sure because there was a couple of things that were not included in CAIR. Eagle-eyed viewers may well have noticed that there's the mail shot article, new hamper and recipe showing in the model here. This is an application for developing content and flowing content into mail shots that was built in about a day using the definition tools of the stage gate system. It really is that simple and hasn't thrown a bug since. Well, that's it. That's CAIR and the CAIR philosophies. There's probably no more than 10 to 20 pages of template to deliver the entire system. It's been extraordinarily robust. It went into service 3 weeks after we decided to build it, and it's been running the business perfectly successfully ever since, and I can't recall a single bug. Might have been the odd very minor snag to start with perhaps field lengths or aspects like that, none of which took more than a couple of minutes to solve. If you want to know more about this philosophy, then please do get in touch. A little note about myself. I wrote my first computer program in 1970. I've been a database specialist since 78. I've built countless databases. I built global distributed system carrying billions, self-healing, 24/7 operation, global close without interrupting the business using synchronization waves. That's going to be the subject of another video. But what I can assure you is that the methods it's espoused here, I haven't really seen very much in the past for which this is not appropriate, and it really does work in terms of the almost zero bugs. It is the Orrery methods made into digital. If you're still here, well done. In the past, people have gnawed their own legs off to escape my presentations. Thanks for watching. I hope you learned something. Get in touch.